There's been several movies on the internet, on YouTube in particular, that show the value of hooking up a car alternator to a bicycle, usually exercise bicycles, to generate electricity. What I'm going to show you is how we've chosen to set up this mountain bike to a Delco Remy alternator, and how the switching is and the circuitry is put together, and then also something useful we can do with it. Today we're going to use a food processor, a 220-watt food processor, to chop some onions. Many people, when they have tried to do this experiment, have used an exercise bike, and the problem with an exercise bike is that whatever speed you turn your pedals or your crank, that's the primary mover for the belt drive across a friction setting for an alternator sometimes. But what I've been able to do here, this is a 21-speed bicycle, and so we've got it on a 4-to-1 rotation where every one turn of the pedals spins the tire 4 times, and then with the current pulley setup that I just pulled off of that Delco Remy alternator, I just kept the same pulley on there. That's a 10-to-1 ratio. So one crank of the pedals turns the alternator 40 times. It's a 40-to-1 ratio. So you don't have to spin it very fast in order to get the alternator up to speed, up to that 2100 RPM or so, that it makes it quite easy to spin while it's under heavy load. First, some basics about an alternator. An alternator is different than a generator in that there are no permanent magnets inside. Instead, you have a field or a rotor coil of wire with some metal plates, and then you also have a stator winding on the outside. And what happens if you just spin the rotor around the stator, then nothing happens because it's just a bunch of wires put together. There are no magnets on the inside. However, if you put a 12-volt charge on the interior coil, then start spinning it, then all of a sudden you have generated electromagnetic force, and the magnetism and the electricity running through the rotor is now inducing a field current in the stator. And it's from the stator that you get electricity, now induced electricity, coming out this post. Now, the problem with alternators is that you have to have power in order to generate power. So, as these alternators are in your car, when you turn the switch on your car, it is connected to a battery. So we have a 12-volt battery pack here. It's nothing large, just some AA's put in series to generate 12 volts. And when you turn the car on your battery, power is given or is directed to the alternator. And it's given through the post connections, as well as these voltage regulator and field sensing wires that come off of the switches that come off of your alternator. Using a bicycle, however, we don't have very much power as we do in a vehicle. So what we're going to do is we're going to start the bicycle running, which will get the alternator spinning, and then we will flip a switch to bring power to the alternator. I'll show you the switch up here at the top. It's just a switch that I can easily get to on the bicycle. And what we have done is that we have put the switch wires in line with the 12-volt battery pack. And then from the 12-volt battery pack, we have a line that goes to the alternator. And when I was doing research on the internet trying to find out how exactly to hook up this alternator, there wasn't much of a circuitry diagram, and I'm not about to draw one for you, but let me just show you what we have done to make this work. We've taken there's a field sensing wire and there is a voltage regulator wire, and these have to see 12 volts in order to maintain the current. All we've done is we've taken these and mounted them right back to the post. This is where the current comes out. So we just attach these to the post. It's the same thing as attaching it to the battery. And then we also have the output wire, which is coming off of the post. This usually takes it right down to your battery. But the output wire we have hardwired into back of a power inverter. We're just using a 350-watt power inverter. And then, of course, the black wire goes to ground. Here we've got it attached to the bracket, which is attached to the outer case of the alternator. The outer case serves as ground. So we have two ground connections. We have one coming from the battery. You'll see this wire going to the black on the battery pack. And then we have the ground coming from the inverter going to the case of the alternator itself as well. So first what we're going to do is bring the bicycle up to speed. I've got it in top gear, and so we're generating the maximum amount of spin possible. So you see right now that the battery still has about 11.5 volts on it. I'm about to flip the switch. Here we go. And you'll see now that we're generating 14.4, more or less, from the alternator. Okay, now what I didn't tell you is that once the process has started, I'm going to turn the switch off now. And so you'll see it goes back to 12.2, but we are still creating 14.4 volts out of the voltmeter, or out of the alternator. So with the bike spinning, it's generating 14.4 volts. We can then use the inverted power to run a food processor, and in this case, we're going to chop an onion. And there you have it. You can hear the inverter power down.